Welcome to the Explainer. Today, we're going to crack the code on something called TRIZ. It's this really cool system for innovation that helps you solve problems, not with some kind of magic, but with a real, structured method.
So you ever been there, staring at a super tough problem, you know you need a breakthrough, but nothing. You've just hit a total creative wall, right? It's a feeling we all get when we're trying to build or fix something. Well, what if there was a way to just smash right through that wall?
Well, what if I told you there's a systematic way to be inventive? Yeah, like a cheat sheet for innovation, basically reverse engineered from the world's most brilliant inventions. That is exactly what TRIZ is. It stands for the theory of inventive problem solving. And it all comes from analyzing literally thousands of patents and realizing, hey, even the most complicated problems get solved with a lot of the same clever tricks.
So in this explainer, we're going to dive into 5 of these really powerful principles that you can add to your own problem-solving toolkit. We'll look at porous materials, color changes, homogeneity, discarding and recovering, and then we'll wrap up with parameter changes. Let's get into it. Okay, first up, let's dive into our first tool, Principle 31, porous materials. And this one is all about getting creative with empty space. Seriously.
The idea here is just brilliantly simple. You either make something porous by adding holes, or if it already has holes, you find a new, clever way to use them. It's all about making stuff less solid to get some kind of new benefit.
And this principle is so versatile. I mean, the obvious example is just drilling holes in something to make it lighter, right? Think about airplane parts. But you can get way more advanced. For instance, a palladium sponge is super porous, and you can actually use those tiny little pores to store hydrogen. It becomes a much safer fuel tank than some giant high-pressure gas cylinder.
All right, next up, we've got principle number 32, color changes. And this one shows how just changing a color or how see-through something is can be a surprisingly powerful way to solve a problem.
You know, this is a great reminder that how something looks isn't just for, well, looks. Visual properties can be a huge part of its function. So this principle gets you thinking. How can I change the color or transparency of something, or even the space around it, to fix my issue?
And you see this pop up in totally different fields. Take a classic photo darkroom. Those red safe lights, that's just changing the color of the room to protect the film. Then you jump over to the super high-tech world of making computer chips, and they use light to change a material's transparency. That's how they create these incredibly detailed masks they need to build microchips. Same principle, totally different world.
Okay, this next one is really interesting because it solves problems by making things more alike, not different. It's Principle 33, homogeneity.
So the idea here is, instead of fighting how different materials react with each other, why not just use the same material, right? If you make the things that have to touch each other out of the same stuff, or at least stuff with identical properties, you can just, poof, make a whole bunch of problems disappear. And the uses for this are so elegant. Think about it. If you're trying to store some nasty corrosive chemical, why not just make the container out of something that won't react with it? Maybe even the same stuff. Or what's the best thing to cut a diamond with? Another diamond, of course. By using homogeneity, you get the absolute best tool for the job, and you sidestep all those messy issues like rust or wear and tear.
All right, let's talk about a principle that is all about being efficient and really resourceful. It's Principle 34, and it has 2 parts, discarding and recovering. Basically, getting rid of stuff that's done its job, or bringing back stuff that's been used up.
So first, let's look at the discarding part. A perfect example is a medicine capsule. It has exactly one job: get the medicine where it needs to go. And once it's done that, its purpose is over. So the solution is brilliant. The outer shell just dissolves harmlessly. It gets itself out of the way. It's a part that literally just disappears when you don't need it anymore.
Now, the flip side of that coin is recovering. This is all about bringing back parts that get used up while something is running. Imagine a lawnmower blade that actually sharpens itself while you're cutting the grass. How cool would that be? That's the core idea here, a system that automatically renews itself. No more maintenance, no more replacing parts.
Okay, our last tool for today is Principle 35, parameter changes. And this is a big one, you guys. This is all about changing the most fundamental thing about an object, its state, its condition, to solve a problem. This one really pushes you to think at a basic level. Like, could I solve my problem if I changed this object from a solid to a liquid? What if I tweaked its concentration, or its flexibility, or its temperature? It's all about messing with a core property to unlock totally new solutions.
The classic example here is moving a gas, like oxygen. Okay, as a gas, Oxygen takes up a ton of space, right? You need these huge, heavy, high-pressure tanks. But what happens if you apply this principle? You change its physical state. You cool it way, way down until it becomes a liquid. Suddenly, you can transport the exact same amount of oxygen in a tiny fraction of the space. It is an absolute game changer for shipping and efficiency.
So there you have it. That's just five of the 40 inventive principles in the whole TRIZ toolkit. Every single one is like this concentrated pattern of clever thinking, pulled from decades of the world's best inventions.
The big takeaway here is that innovation doesn't have to be some random bolt of lightning. It can actually be a system, a process. If you can frame your problem and then apply the right tool, you can actually steer yourself toward a breakthrough. So, now that you've got a few of these tools, what problem are you going to solve first?
Because at the end of the day, the big idea behind TRIZ is that invention isn't magic. It's a science of patterns and principles. So the next time you feel stuck, remember these principles. And don't just ask yourself, what if? Ask yourself, okay, how can I systematically change this?